Hi everyone, Assalamualaikum warahmatullahi wabarakatuh. Welcome back to the subject CHM421, which is analytical chemistry. We will continue our video on the topic 1, which is units for quantities and concentration. However, in this time, this video will discuss about the significant figure and also the uncertainty. There are two types of numbers, either exact number or inexact number. Example of exact number, uh, for example, in 1 dozen of egg. So we know in 1 dozen of eggs, it containing of 12 eggs, or exact number, we have 10 fingers or 10 toes. This is the exact number. However, in the same time, we also have inexact numbers. Inexact number normally is involving measurement. For example, the volume of soya drink in a glass. So the volumes is inexact. Is very depending on the unit. For example, if our glass, the maximum volume is 250 milliliter, so it can be less exact. So it's depend on the significant figures. In this exact number, 250 ml, so the number of significant figure SF is 250 significant figure, 2 significant figure. So this one is 1 significant, 2 significant, 0 is unsignificant figure. This why in 250 ml, it's 2 significant figure. If we have, for example, 100 ml, so this one is 1 significant figure. We will discuss this one in detail on the next slide. So more precise, maybe it might get 260 ml rather than 250. So to be exact, to be precise, maybe 268 milliliter. So this one is 3 significant figure. And even more precise, it would be uh, in decimal point, 267.8 0.5 milliliter. When you round up, you get it to 68. So the significant figure for this number 267.5 is for significant figure. So in this case, if it involves scientific measurements, uh, we will include the significant figure. So what is the significant figure or significant numbers? In any measurement, the number of significant figure is very critical, meaning that it's very important. The number of significant figures is the number of digits believed to be correct by the person doing the measuring. It includes one estimated digit. For example, for this uh, uh, 267.5, maybe you round up and then you can also present it as 268 milliliter, or it can be even written as 250 ml, meaning that the person can do the person doing the experiment or doing the measuring can do the correction. and he or she do the estimation digit. So what is significant? Uh, is non-zero digit are always significant. Non-zero is always significant, meaning that it's more than zero, all significant, all significant. Okay, all uh, significant. It's non-zero, always significant. Zeros or zero are sometimes significant, in sometimes it not significant. It depending on the location in the number. For example, if we have 100 or we have 100.5, so the zeros is can be significant or it can be not significant. It's depending on the location. So the zeros in 100 is not significant. So this is why the 100 is only one significant number. But the zero in the decimal point, 100.5 is a significant. So this is four significant number. So zero, you have to be very careful. All right. Leading zero are never significant. Okay. Embedded zero are always significant. Trailing zero are significant only if the decimal point is specified. So we will see the example of this leading zero, embedded zero, or trailing zero. Okay, zero between non-zero digit always significant. This one is significant. So we have three significant figure. Leading zero meaning that the zero located in front, leading zero is always never significant because this 0.0497, it can be written as 4.92 times the power minus 2. Uh, 1, 2. So this is 3 significant figure. Why 3? Because this one is not significant, 0 is not significant, it's leading 0 only 1, 2, 3. Okay. For the trailing 0, embedded 0 are always significant. Embedded, this one is embedded. Location zeros between non-zero is embedded. So trailing 0 is only significant if the decimal point specified. So let's say we have a decimal point like this, the number in the decimal point. So 50.0, so it's 3 significant. 50 point is, they have decimal point, is 2 significant. But however, if only 50 with no decimal point is 1 significant. Okay, so you can see if we have 5.0 versus 50. So this one is two significant figure because decimal point are specified. This one is no decimal point. So non-zero digit are always significant. Zero sometimes significant, sometimes are not, depending on the location. So zero in this location is not significant, so it's only one significant figure. All right. Okay. So trailing zero, we is already covered here. Is trailing zero. It's very depending on the decimal point. So you can read if you wish. So you can try to predict the number of significant figure. So for this one, the first one, 10.034. So all significant figures. So we have five significant figures. Second one, we have four significant figures. The third one, only two. Uh, Also, the fourth, only two. This one is only two because this one they don't have any decimal point, only two. So this one is three significant figure because they have a decimal point. This one only three because the leading zero is insignificant. This one only two, the leading zero is insignificant. This is three significant figures. This one is only three significant figures because it's no decimal point. So the last zero is not significant. The zero between non-zero digit are significant. Okay, I hope you can understand in terms of significant figure or significant number. So, significant number of figures in numerical, we can rounding off. So, if you want to rounding off the rule, if the digit to be discarded more than 5, we increase the preceding digit by 1. If digit less than 5, do not change the preceding digit. This is the rule of rounding. During the addition and subtraction, the last digit written in the sum or difference is determined by the lowest number of significant figure to right of decimal place in any of the original number. So we will see the example later. In multiplication and division, answer should be rounded off to certain same number of significant figure is original number with smallest number of significant figure. Okay, average and also proportion. So this is the example of significant figure during a process of addition and subtraction. When we adding or subtracting, we do not extend the result beyond the first column with the doubtful figure. For example, we have 1.592 plus 2.1 plus 129.4917 plus 0.29462. So it's a different form of numbers we try to add on. So when we consider the significant figures, we have to arrange it nicely. So all the decimal point put on the same place. So we can obtain 133.47832. So uh, the numbers before the decimal point are significant, and then we will choose the for the addition, the last digit should be retained in the sum or the difference is determined by the lowest number of significant figure to right of decimal place in any original number. So among these, the lowest the lowest significant figure is 2 significant. The lowest is this one. Okay, this is the lowest significant figure 2. So we the last digit should be written according to the lowest significant figure. So because the lowest significant figure in this case is 2.1, so we will write this number is 1 point, sorry, uh, we write it 133 point because the lowest significant figure only one digit, so we have to round off, so point 5. So total 4 significant figure. Okay, so we report in this way. So because this one is more than 5, so we round up to it on, it become 5. Okay, all right. So some easy exercise. If we have 16.874 plus 2.6, so we can obtain 4, 7, 14, 8, 9, 19.474. So the lowest significant figure is 2.6. So we will stop until here. So we will report only 19.5, which is a 3 significant figure. Okay. So same goes to this example, 16.874 minus 2.6. You can obtain 4, 7, 2, 4, 14. So this is the lowest significant figures. So you will report this is 14.3, which is 3 significant figure. So I hope you can understand how do we consider the significant figure in the during the addition and also subtraction. Okay, uh, significant figures for multiplication and division. When we multiplying or dividing the answer will have the same or dividing, the answer will have the same number of significant digit is the less accurate number used to get the answer. Less accurate number meaning that is the smallest significant figure. Okay, so when we divided 2.005 gram divided to by 4.95, we obtain 0.405 gram. 2.005 divided 4.95, you can obtain 0.05. 0, maybe it's 0, sorry, it's 0.405, 1. Yeah, 1. So we will report based on the least accurate number. So it's the smallest significant figure. This one is 3 significant figures. This one 4 significant figures. So we will report this one is only 3 significant figure. Okay, this one is not significant. So this is 3. This is 3 significant figure. So for multiplication or division, the last answer, it should be based on the smallest significant figure. Also, thanks to the addition and subtraction, the final answer it should be the lowest significant figure. All right. Okay. So for this one, if we have 16.824 multiplied by 2.6, we obtain the result of 43.8724. So the lowest of significant figures is this one, which is two significant figure. So your answer it should be 43, 43 because it's two significant figure. The lowest is two significant figure. So this is the answers. 1.16, 16 point what? 16.84 multiplied by 2.6. So the answers is 43.8724 because the lowest significant figures is this one, two significant figures. So the result it should be two significant figure, which is 43. Oh, sorry, this is divided. So 16.874 divided by 2.6, you get 6.49 because the lowest significant figure is 2. So you have to write the final answers with 2 point, sorry, it's not 2, it's 6. You have to write in two significant figure is 6.5, two significant figure. Okay, so I hope you can understand in terms of how to write the correct based on significant figure for the addition and subtraction, as well as the multiplication and division. Okay, now we try to understand the significant figures in the laboratory glassware. Measuring, for example, we want to measure the volume of the solution in the lab. So the example where significant figure is important. So during the lab measurement, this is where we will apply the concept of significant figure, measuring volume in the laboratory. So we have various types of glassware for measuring the volume of the solution. We can have a beaker with volumes marked on the side, or also we can have graduated cylinder, or even we can have bearer. Okay, so if we have a beaker like in this diagram, smallest division is 10 ml. Okay, this is 10 ml. 20, 30, 40, 50, 60, 70, 80. So the smallest division is 10 ml. So we can read volume to 1 over 1 over 10 of 10 ml or 1 ml. So we can subdivide it. Okay. Volume we read from the beaker has a reading error 1 ml. So volume in this beaker is 47 plus minus 1 ml. Okay, because we can measure the we assume the 1 ml. So we can measure 47. We just do the estimation. It's about 47 plus minus 1 ml. So this one is 47 uh, is two significant figure. Two significant figure, one certain digit, the others is uncertain digit. One is certain digit, the other is uncertain digit. Okay. Same goes to the graduated cylinder. We note that the surface of the liquid is normally curved, so we call it meniscus. So this is uh, meniscus. When we read the volume in the graduated cylinder, we will read the bottom of the meniscus. So we will read here. Our smallest division is 1 ml. Okay, because this graduated cylinder 35, 36, 37, 38, 39, and then 40. So the smallest division is 1 ml. Like this, the smallest division is 10 ml. So, so the reading error in this case is 0.1 ml. Okay, so the reading error in this one is 1 ml because we can do a sub the most smallest value 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, and then we get 30. So the reading error is 1 ml. However, in this case, the smallest division is 1. Uh, 35, 36, 37, 38, 39, 40. So the reading error is 0.1. So in between this one, we can consider 35.01, 35.02, 35.03, 04, 05, 06, 07 until you obtain 35 point until you get 30, 36. So the volume in this graduated cylinder, you can write it 36, 30, uh, this one, 36 point what? Point 5. Okay. So plus minus reading error 0.1 ml. Okay. This is the way to write include the reading error. So precisely the value can be 36.6 ml or it can be 36.4 ml because 0.1 ml is the reading error. We do the estimation. So it's three significant figure to certain, meaning certain, this is certain. 36.5. So it's two significant figure. This one is certain. Certain is confirmed. This one is uncertain. It's depending on our estimation because it can be 0.6, it can be 0.4. So one uncertain. Okay. So in this case, we write it 47 uh, plus minus 1 ml. So they have two significant figures, and this one is certain because it confirmed, and this one is uncertain, is depending. It can be 48, it can be 49, or it can be, because the reading error 1 ml. All right. Okay. Graduated cylinder is quite similar with the biorate. Smallest division is 0.1. 21, 20, sorry, 20, 21. So meaning that here it should be uh, 20.5. So this one it should be 20, 0.1, 0.2, 0.3, 0.4, and then 0.5. So the smallest division is 0.1 ml. So every mark is 0.1, 0.1, 0.1, 0.1, 0.1, 0.1, all 0.1. So the reading error, it should be 0.01. Okay. Yeah, so in here is 0.01. So the volume reading is about 20, is about 20 point, how much? Uh, 20, 38 is about 4, is 1, 2, 3, it's about 23, 8. Plus minus 0.01 ml. So it can be 2039 or 2037. So from here, you can have four significant figure uh, to certain is too certain. 2, 0, and 3. Definitely no. Okay, it's a 3 certain. Okay, it's a certain because we are confirmed. Uh, 20 and 3 is confirmed because this is 0.3. This one is 0.3. So it's uncertain is 8. So it's only have one uncertain, which is number 8, that we have to do the estimation. Okay. All right. So you have to remember the reading error based on the smallest division, reading error based on the smallest division, reading error based on the smallest division. So I hope you can understand the concept of the significant figure and also uncertainty, uncertainty. Is a conclusion. The number of significant figure is directly linked to the measurement. So if you want some water, if you want about 250 ml of water, if you want about 222 ml of water, if you want 22.52 ml of water. So it's a very doubtable in terms of measurement. So if only a rough estimate of volume is needed, the bigger volume is satisfactory to significant figure. Otherwise, one should use the graduated cylinder to significant figure, or the much better using a burette for significant figure. So the lowest the significant figure is less accurate is compared to the highest significant figure is more precise. Okay, I think that's all for this video. Thank you very much. I see you again on the next video. Assalamualaikum warahmatullahi wabarakatuh and bye bye.